We are going to examine the concept of net zero, around which many promises are being made by various countries. First, let us look at what is the status of emissions and whether the promises are making impact on the emissions and to what extent they are making the impact. Let us review the story. It was in 1988. James Hansen, scientist from NASA's Goddard Institute for Space Studies, gave testimony to the US Congress that greenhouse effect has been detected and it is changing our climate now. So this has been realized in 1988. This was before WTO, before collapse of USSR, before rise of China as a great power, before this massive amount of globalization. So if we really acted on our understanding, then we would not have done many of the things, but we did not. In 1992, Earth Summit was an important thing happened, and conference of parties meant exclusively to discuss the greenhouse emissions started in 1995 in Berlin. That was the first conference, COP1. And then every year they were meeting, and COP26 was held in 2021 Glasgow. COP3 held at Kyoto was an important development, and COP21 held in Paris in 2015 was an important development. So from 1990s, countries were promising, or they were saying that they were trying to do something about reducing the greenhouse gas emissions. Okay. But what is the impact of these promises? It is this. Greenhouse gas emissions have been on the rise. Global carbon emissions, from 1900 to 2014. 1900 to 2014. So 1900. It's 2010, 2014. In 2014, it is less than 10,000 million metric tons. 10,000 million metric tons is 10,000 gigatons. Currently, or in 2019, carbon emissions were 10 billion metric tons, that is 10 gigatons. In 2019, 10 gigatons. So 10 gigatons of carbon. See, there are three ways of looking at it. One, CO2, two, CO2 and CH4 and N2O and others, all measured in terms of CO2 equivalents. And third, in terms of carbon. CO2 in 2019 was released to the extent of 37 billion tons. And all the greenhouse gases put together, it was 51 billion tons of CO2 equivalent. But if you are going by carbon, that was 10 billion tons or 10 gigatons. So you can remember these numbers of 37, 51, and 10. They are 2019 related. Okay. And seeing the graph closely, we discovered the problem in 1990s, 1990. From 1990, there was only rise. From 1990, it's only rise. It's like this. In fact, from 1990, the rise was more steep. It means we emitted much more after discovering the problem, because emissions were related to globalization phenomenon. It was after 1990s, China's growth increased, India's growth increased. China and India are being considered most recently industrialized countries. So, if we had done something when we discovered, things would have changed. So this is about annual emissions. Then what are cumulative emissions? So cumulatively, this is about carbon dioxide measured in terms of ppm, parts per million. This is a cumulative thing because CO2 released will stay for 300 to 1000 years in atmosphere. So considering industrial revolution from 1750, whatever we released from 1750, they are there in the atmosphere now. Until 1750, the release was much less, from 1000 like this. But from 1750, hugely improved. And 2000, very steep. Okay. As of now, in 2020, carbon dioxide, this is about carbon dioxide, not other gases, 412 parts per million. And this figure is currently rising at a rate of approximately 2 ppm per year and accelerating. This ppm is a very significant figure because from this ppm, one can find out from Earth history what was the ocean level and other variables given that ppm. Of course, how fast this ppm is rising is is another variable that affects life adaptation. So it means huge rise is taking place in the last from 2000 plus. Okay, and one important accord was Paris Accord. In 2015, Paris Agreement was reached, and nations said that they want to not to warm beyond 2C by 2100. The goal is about 2100, not to warm beyond 2C, but ideally limit below 1.5C. But in 2020, the temperatures are about 1.2C. So we are at 1.2C, and according to Paris Agreement, we don't want to cross 2C by 2100. How is that possible? It is in this context, countries signed that they would peak by 1 year and then they would attain what are called net zero targets. Net zero meant that there will be some emissions, but they will be offset by negative emissions, plus and minus zero. So the concept of negative emissions came, negative emissions. So net zero targets have negative emissions. And according to UN Environment Program, so it's an Environment Program, to stay below 2C, to stay below 2C, there have to be many negative emissions starting from this 2030. And in 2100, almost 20 gigatons of negative emissions. And positive ones were less than 20. So these were the estimates. So it means on the basis of negative emissions, we want to stay below 2C. So negative emissions are a part of 2C target. Okay. So supposed to reach a peak at one point and then like this. But the point is how to reach these, what is the technology of negative emissions? What is the technology? That is the issue. One may think negative may come from plantation, forestry. Okay. So this also was seen as a solution. But it is found at the scale that is required, forestry is not a solution. Because it is like this. Restored forests in the new or restored forests in areas of Russia, in the area of Russia size, can only generate 200 billion tons of CO2. So if the entire Russia is forested, it gives only 200 gigatons. Whereas this calculation requires, according to 2018 IPCC report, 100 billion tons to 1000 billion tons of CO2 to be removed by 2100. Its median value of 730 billion tons of CO2 need to be removed. That is more than 10 years of emissions. So 2C plan required 10 years of emissions or 730 gigatons of CO2 to be removed from atmosphere. And for that, afforestation, greening is not the solution, or that is not adequate solution. That is not at all adequate. We just don't have that much amount of land. So what were the technologies that were being proposed here? One technology is carbon capture and storage, CCS. Carbon is supposed to be captured, released. Carbon is supposed to be captured, and then stored in some underground facility. Captured and stored. And in a way, what is stored won't come out. But what is the status of this technology? The Economist gives that in 2019, the world has 2,500 coal power stations, thousands more gas-fired stations, and steel plants, cement works, and others. Means thousands of industries. Of them, only 19 has some offer of carbon capture and storage, according to Global Carbon Capture and Storage Institute, GCCSI. It means, it says that only 40 million tons of CO2 being captured from the industrial sources. 40 million tons out of 40 billion. That is about 0.1% of emissions. So 0.1% of emissions were being captured using CCS. But why is it so low? It is essentially, it is a very costly technique. There are no cost advantages. So that is why many have not gone. But why did some go at all? Some went because some stations, for example, those involved in oil, needed carbon dioxide to get more oil from certain wells. So they captured carbon dioxide at certain places from certain wells and used carbon dioxide to extract more oil as a part of enhanced recovery. So it is in that context some technology was developed. So this was about CCS. But CCS in itself is not negative emission because it is only taking what is being emitted. But can this CCS be used as a negative emission? It is here a new technology is proposed. This is called bioenergy CCS. Bioenergy CCS. You plant timber. This is a positive thing. Sorry. This is a negative thing. Plant timber. This is negative. But burn it to make electricity. At one place, this is being converted into wood pellets, replacing coal. But CO2 from pellets is taken and stored in subterranean geological storage. It means you are adding forest, that is a negative emission, and using it to produce electricity, but carbon dioxide that is emitted during the production of electricity is being stored. So CCS is being used along with production of bioenergy. But even this hasn't become very popular. It is because essentially the cost is an issue. And also much more land is required for BACCS. It is essentially biofuels plus CCS. So even this hasn't become very successful. But a technology that is widely being talked about now is what is called direct air capture. Direct air capture. Direct air capture refers to capturing carbon dioxide from air directly, which is not easy because carbon dioxide is at a very low concentration of only 0.04%. And then storing it underground. So it is similar to CCS, but directly from air. So most people, most companies and countries are currently talking about this DAC. It is based on this DAC, net zero targets are worked out. So when a country says that it is going to be net zero by 2050, then it means that it is going to use DAC to offset its emission. Okay, so DAC is the main strategy in all net zero targets. But what is the status of this technology? It is found that it is very costly. For example, a Swiss company Climeworks is running one in Iceland, and it is producing 4,000 tons per year. But the cost is $600 to $800 per ton. And it can charge $1,000 per ton if anybody wants his CO2 to be stored. Okay, or he is emitting, but storing is here. Okay, it's emitting and storing here. It is $1,000 per ton. And it's very huge. But a large scale CO2 removal facility in Scotland is being planned to remove 1 million ton of CO2 per year, which equals 40 million trees. So 1 million ton of CO2 per year equal to 40 million ton means 1 ton is equal to 10 trees. Okay. And Bill Gates thinks that this thing can come down to, now it's costly, some come down to around $100 per ton. But $100 per ton is not easy. It's very costly. And if one wants to remove 50 billion tons that is being emitted now, it costs around $5 trillion per year. So as of now, if the technology improves, then maybe at a very to very high levels of scale, it may come down to $100 per ton. Even then, it is very costly. So to what extent countries and companies will pay this much to reach their net zero targets? And especially when they have and when they are not pursuing much cheaper alternatives of wind and solar. That is why some people think these all postponing the problem, evading the issue. Just say by 2050 we'll be net zero, 2070 will be net zero. How can you say you will bank on a technology which is not existing and which may never exist, and even if it exists, which is extremely costly? Now people have this impression that if more and more announce net zero, more countries announce net zero, then you solve the problem. In fact, a company may achieve a net zero, a country may achieve a net zero. For example, a company may achieve a net zero through afforestation and some direct capture. A country also may achieve. But when many countries want to achieve net zero, afforestation is not a solution because you don't have enough land, and DAC has not developed. So how will this be possible at all? So, and more importantly, when the crisis is so imminent, how can one talk about 2050, 2070? So if one is serious, one should give targets of what is going to be done immediately. Next 3-4 years. and how CO2 is going to be reduced. That's all. Very clear, specific reductions in short term. Verifiable. So net zero by 2070 or 2050 is meaningless because we just don't know what is going to be there by that time. And more importantly, you can't make those promises on non-existent technologies. So it gives the false impression that we are doing something because after all, we are committing net zero. So we are nowhere near 2C. We are nowhere near containing 2C. And net zero promise doesn't make any sense. Marx long ago talked about religion. He said religion is used to deceive people, deceive others, and delude oneself to escape from a problem. So in that sense, he called religion as a opium. Now we seem to be using science as an opium. Without confronting the problem. But what is the nature of the problem as of now, if you, given what we are doing? See, we discussed many tipping point scenarios and tipping cascade. But without having to think in terms of tipping cascade, if you just go by the rise in ppm, then you are getting a very frightening picture. So as per Ku, Y and Ramanathan V 2017 studies, going by ppm account, assuming that emissions will peak by 2030, and by 2030, 437 ppm is going to be there, which will give a rise of 1.6 C by 2030. And by the same calculation, 2.4 C by 2050, 2.4 C by 2050. Without thinking of tipping points. So in a way, we are simply gassing ourselves. And not realizing how serious the problem is. And if we have 2.4 C by 2050, then definitely by 2.4 C, many tipping points will be unleashed. So what will be our fate? So it appears we are simply gassing ourselves to great pain and sorrow. If you disagree, please share your feelings through commenting on this video.